Okay, today is Module 5,
Yay!
Lesson 1. And what's today's theme?
All about the face.
All about
That's the face.
Actually, we're going to be all about that height. But that doesn't work. Okay. We're going to start, this unit is geometry, so we'll be looking at different shapes, area, all kinds of fun stuff. So let's start by reviewing different shapes. This is page 1, gentlemen, of your module. So what's this first shape on the top left? I gave you some names on the board to help you. Right triangle, so please write that in your notes. What's this middle shape on top? Yep, parallelogram. This one over here. Oh, it's so cute. And down here on the bottom left. Uh-oh, I only see one hand up. You're all going back to pre-K.
Yay.
Rectangle. And what's this last shape? Process of elimination. Trapezoid. But now, I have a question. I have a couple, actually. What could we call the parallelogram and the rectangle and the trapezoid that we can't include the two triangles in? Nice, quadrilaterals, because they have 4 sides. Quad means 4. But what can we call all of those shapes that have 3 or more sides? No, gentlemen, no, because a circle is a shape, but a circle does not qualify as this. 3 or more sides, closed figure. Ooh, I gotcha. Polygons. And then we have our quadrilaterals, we have our triangles. My next question. Why is this a trapezoid and not a rectangle? And not a parallelogram? How come?
Because the sides on the top and bottom are different.
Not because they're different lengths. There's a reason why they're different lengths, but that's not why that's called a trapezoid. Well, this side is parallel to this side, but the other set of sides are not parallel. So the trapezoid has only one set of parallel sides, where the rectangle has 2 sets of parallel sides. So this is parallel to this, and that's parallel to that. The red's parallel to red, green is parallel to green. But on this one, our red sides on the trapezoid are not, well, no, I just made them green. Used the wrong marker. But trapezoid has only one set of parallel sides. That's another example of a trapezoid. So it can have right angles like a rectangle, but one set of parallel sides. Okay, just a little extra thrown in there. Sprinkle a little extra on. Okay? Ready? Let's just take a look at that first rectangle. How do we go about finding the area of a rectangle? Yeah. Oh, that's right. So area equals length times width. Will that work for a parallelogram? No? Yes? Take a guess. How many of you think yes, we could use length times width for a parallelogram? How many of you think no? How many are voting no just because it must be no, otherwise I wouldn't be asking? Okay, there's a reason why I'm asking. I'll just tell you the answer. The answer is actually no. We can use length times width because here's our length, and that would work, but our width here is actually going to be too long, and I'm going to show you why. Let's take a look at this parallelogram. I'm going to use this dotted line and cut off that triangle at the end. I'm going to take that triangle at the end and bring it over here. And voila, what did I make? It's a rectangle. So I have my length, and here, God bless, is my width. Are we okay with that? But now suppose I put it back the way it was. I'm going to have to bring my width over here. Because if I turn this, is that side the same as my width? No. My width is longer than that length and the width. That's too long. So if I use length times width, I'm not going to get the correct area, am I? It's going to be too big. So instead of using, my length is the same. See how my length is the same? But my width was too big. My width is longer than this. So now wait a minute, I can't have two widths. It's freaking me out. Which W do I use? Anybody think of a better name for what I can call this dotted line that I made? Instead of calling that width, I can call that my, it's like showing me how tall it is, right? So it's showing me the height, exactly. So we'll call that height. You might also see it called altitude sometimes. You might see altitude, but that's the height. So when we're doing a parallelogram, we're actually going to say that the area equals, we're not going to call it length anymore either. This one I don't know. Why don't they, again, we're going to, all about that? Base. Base. So we're going to turn it into a base. And we like to think of it as base or bottom because when we draw that height, it has to go down to that base. And when it hits that base, it's going to form a right angle. So the formula for a parallelogram is base times height. We okay with that? I just wanted to show you where the formula came from and why we use the height instead of the width. Because we saw here, I'll show you again, that if I turn that, the width is too big. And that wouldn't work for base times height, length times width, which is the rectangle. Okay, so let me put these back. All right. Any questions on what I did? Yes.
How would you find volume?
Oh, we'll get to that. Okay. Because we wouldn't do volume of that because it's a two-dimensional figure. Volume has to be a three-dimensional figure, like a pyramid or a prism or a cylinder. Okay? So now let's take a look at this. Let's practice one together, and then you can start taking your notes. So here is a rectangle. Gentlemen, my length is 7. My width is 3. But if I cut out a piece and brought it over here, now I could see the parallelogram. So I would use my base, which is 7, and my height, which is 3. Does everybody see where that height came from? Ah, it ungrouped. Okay. Now where's Waldo work? We're going to do a nice, neat ladder, top to bottom, following the steps so we don't lose points. You want to get into this habit because when it gets into bigger problems, you can't use that mental math. You want to know how to do the steps. So remember, we practice on an easier course, so we're ready when it gets harder. So first step, formula. Replace your variable with the value. What is the base? What is my height? So area equals 21, and area is always squared, okay? Now where's Waldo work? Top to bottom. Area equals, area equals, area equals. Okay? Let's try some together. So, number 1. Then now we're in your notes on page 1. Number 1, step 1. Area equals base times height. Now what is my base? 6. Now because there's no other number, we know that that 6 is the whole base. You might see some down the road where you have to add the two pieces together to equal the base, but for today, that represents the whole base. What's my height? Careful, careful. 4. 6 times 4, so area equals 24 centimeters squared. And let's try C. Let's jump down to C. Area equals base times height. Area equals what times what? Matt? And Michael, sorry.
12 times 7.
Yep. 12 times 7 is, and then I label it feet squared. In case I forget to say it later, when you're doing your homework, you may use a calculator. Okay? All right. Let's keep going. Now, put your pencils down. I just want to show you something. This is just a what it means moment. Not you're ever going to have to do this moment. Okay? You're never going to have to draw this model. I'm just trying to show you what it means right now. Well, here we have a different type of parallelogram. Well, I mean, it's still a parallelogram. It's just a different shape. So when I go from my opposite angle and I draw my height down, did that hit my base? No. So that height is no good. Really not a good idea right now. So we can't draw the height like that. We have to find a different way to draw the height. So let's break this shape down into different pieces. Everybody should be looking at the board. Pencils should be down. Okay? So here, I'm going to cut off all these little triangles. When I cut off those triangles, I'm going to move them over here. And what I ended up doing was creating rectangles. So now over here I have all my rectangles. If I just push all my rectangles together, I make one big rectangle, and here is my height. So what I can do is if I bring this height over here, that is my height. So this time, instead of drawing the height through the shape like this, because that doesn't work, we're going to use this other corner and draw the height outside the shape. And the base is still just the base. Even though I extended that dotted line, your base is still whatever this measurement is here. The dotted lines always represent a measurement. The dotted lines never represent a side. Okay? So let's try some. So for number 2 in A, just draw your height for A. You're going to go from the upper left-hand corner. Be very careful that you're drawing a perfectly vertical line, and so that when it hits your base, you're forming a right angle. You want them to be perfectly perpendicular. There should be rulers in your buckets. Last period told me that they've disappeared. A lot of them are missing. So if you have a straight edge, that would probably be helpful. But make sure you're drawing a dotted line, because a dotted line represents a measurement, but a solid line would represent a side. So make sure you're representing a dotted line. And a lot of times, if you notice what I did on the board, they will cut it off with a, not cut it off, they'll label it as a right angle. It's only a height if it forms a right angle with the base. Anything else? Any other hints? I'm thinking of like classifications, qualities. Okay, so let's take a look at 2B. We can go from the inside angle. Draw this one. A lot of people were like veering to the right. So be very careful with B when you're drawing your height. Drop it straight down so that when it hits the base, you're forming a right angle. And you can draw the little right angle. Bam, right angle.
Where are you getting the numbers from?
I used my ruler and I measured it. The directions on your paper say to measure them with your ruler, but I didn't want to do A. I just wanted to practice drawing it. But for B, I do want to solve B. So I measured it with the ruler, and you'll just have to trust me. God bless you. The base is 1 and 1/4 inch. God bless you. The height is 1 3/4 inches. So please label the measurement of your base and your height. If we measured the side would have been 2 inches. Thank you, Matt. This was 2 inches. But we don't need that. But I just want to show you how the side is longer than the height. So what's the first step in finding area? Everybody? Formula. Now I'm going to replace my base with 1 1/4. Replace my height with 1 3/4. What? Fractions? How do we multiply fractions? Actually, they're mixed numbers. If you want to get technical. Those are mixed numbers. So, what do I have to do? No, well, I could, but I don't want to. I want to leave it as fractions because I want to remind you how to multiply fractions and mixed numbers. Improper fractions, okay? Because then they could be repeating or non-terminating decimals, and we're just going to leave them as fractions, okay, for today? So, mixed numbers, change them to improper fractions. So, ask Ma. Multiply, then add. Ma. So, 4 times 1 is 4, plus 1 is 5. My denominator stays the same. 4 times 1 is 4, plus 3 is 7. My denominator stays the same. I said you ask Ma, you multiply, and then you add. Don't worry about it. What's my next step for multiplying fractions? Multiply my numerators. Oh, yay, common denominators. Does that matter? No, we don't need common denominators. So I can multiply my numerators. 5 times 7 is 35. Do I multiply my denominators? Yes. 4 times 4 is 16. But I'm still not done. I'm going to change that improper fraction to a mixed number. I'm going to go to my messing margin and divide because I know my fraction bar means to divide. 16 goes into 35 twice with 3 left over. So 2 with 3 left over, my denominator stays the same. Can 3/16 be reduced? No, thank goodness we're done. But I have to label it inches squared. Now we've done. Questions? Where did you get the 16? Where did you get the 2? Where did you get the 3? Any questions on where any of those numbers came from? All right, now for 2C, let's just draw the heights. This one, if I went from my corner, gentlemen, if I went from my corner, would I intersect at my base? No, so I can't do that. So I have to draw it on the outside. So drop that down. You don't want to hit the other side, you want to hit that base. So let's stretch the base out. Let's drop our altitude or our height from that outside angle. Now, if we measure it, first period really argued. They did not like that the base was 1 inch and that the height was 1 inch. Doesn't the height look taller? I promise you they're not. The base and the height are both the same in this one. In this example, the base and the height are both 1. You take the ruler and you line it up and then you read the numbers. No, I'm just saying it almost looks like an optical illusion for this one, but they are equal. Okay? We're not going to find the area. 1 times 1 is 1. Done. But I do want to do number 3. So we're going to finish strong. All right? We had some good warm-ups. We see the finish line. We're going to kick into high gear and finish strong. We're going to stop calling out and interrupting. We're going to stop asking Ms. Lubuski to speak over us, and we're going to be good listeners. Thank you. If the area, oh wait, they're giving us the area? If the area of a parallelogram is 3542 centimeters squared, one person smile, thank you for that. And the height is 1/7 centimeter, write an equation that relates the height, base, and area of the parallelogram. So we have to write an equation. And then to solve. All right, first of all, what's the formula for area of a parallelogram? Right, so we'll write that first. Area equals base times height. And now we have to replace the variables with the numbers. So, the base is... We don't know. So, B. What's the height? 1/7. Do we know what the area is?
We do.
35 over 42. So there's our equation. The area equals base times height. So 35 42 equals the base times 1/7. So now we have to find out what B is. How do I find out what B equals? How do I get the B alone? If only we spent all of Module 4 learning how to do that. Give me 2 words. Give me 2 words. I have to use the... Sorry. Answer me! What is it? Inverse operation. So right now, B is being multiplied. So I have to do the opposite, which is division. So 35 over 42 divided by 1/7 equals B and 1/7 divided by 1/7. So now on my right side of my equal sign, my 1/7 and divided by 1/7, those cancel each other out. So I'm left with just my B. Yay! I just wanted to find out what B is. So now on the left side of the equal sign, I have to divide those fractions. Oh, if only we learned how back in Module 2 how to divide fractions. How do we divide fractions? I think it was Module 2. What do I have to do? What do I have to do? I can't just divide them like that. Yeah, multiply by the inverse is what he said. Multiply by the inverse. So I keep my first fraction because that's my quantity. That's what I have. I can't change my quantity. I change my division to multiplication, and I take the inverse of the second fraction only. Oi, 35 times 7. This is where I said you could use your calculator for your homework, but this is not difficult. A little time consuming, but not difficult. I go to my margin. 35 times 7 is 245. Then I multiply my denominators. 42 times 1 is, or at least they cut me a break on that one. All right. I know my one-time table.
Congratulations.
Am I done?
No.
No, I cannot have an improper fraction. So I'm going to come to my margin or grab my handy-dandy calculator. And I know that 5 times 42 is 210. So I have 35 left over. So this becomes 5. And 35 over 42 equals B. But I'm still not done. 35 over 42 can be reduced. They're both divisible by 7. So 5 and 5, 6 equals B. If you'd rather write it that way, because we have to label it. How do we label it? What is the unit? Oh, you're going to make me nervous now? But the unit, it's only the base, it's not the area. So we're gonna label it. Is that what the unit is?
Yeah.
Centimeters, yes. But it's just plain old centimeters because it's just the distance. We already knew what the area was. If we went back and looked at the equation, they used centimeters squared up here for the area. But our distance is just centimeters. The last problem on your homework, number 9, is this. So use this to help. Boy, I've really been talking over you all day. So use this to help you with your homework tonight for number 9. It seems like a lot, but some of them are pretty short and quick to get through. Your homework, absolutely, positively, no ifs, ands, or buts, must be done on loose leaf. And you absolutely, positively, no ifs, ands, or buts, must show all your work organized, formula to labeled answer.